All right, today we're going to talk about solving quadratics by factoring when the quadratics are in standard form. And I want you to remember what standard form is this right here. This is standard form, ax squared plus bx plus c. And what we've looked at in the past is we've looked at solving quadratics when they're in this form, x squared plus bx, all right, plus c is equal to 0, where your a value right here is actually a 1, okay? Today what we're going to do is we're going to look at some examples where your a value, all right, is not going to be equal to 1. So you see we have an a value of 3, we have an a value of 9, we have an a value of 18. And I just want to go ahead and talk about, how to go ahead and solve these quadratics when that a is not 1, okay? So whenever you go ahead and you have a quadratic trinomial where the a value is not 1, what you have to do is you have to take this a value out, and you also have to take the c value out, and you have to find the factors of these numbers, okay? So you're going to find the factors of 3, and you're also going to find the factors of 8, all right? So for the a value, my factors of 3 are 3 times 1, okay? And for my 8, my factors of 8 are 1 times 8 and 2 times 4, all right? Now what we're trying to do is we're trying to go ahead and find a pattern between these sets of factors and these sets of factors that'll go ahead and get me to 10, okay? So as always with factoring quadratic trinomials, we're going to go ahead and we're going to put in my 2 sets of parentheses, all right? And we're going to try and break it up now. So you try and take one of the factors from your a term, and you multiply it by one of the factors of your c term, all right? And then you take the other factor and you multiply it by another factor over there, okay? So I'm thinking that if we want to get to 10, what we could do is we could do 3 times 4 over here, all right? So we would do 3 times 4, and that would go ahead and get me to 12, okay? Now, if I'm using this set of factors with this set of factors, I already did the 3 times 4. Now I'm going to want to do the 1 times 2, and that would go ahead and give me 2. Now we're trying to get a positive 10, so I need to make this a negative right here, which means then that I would make this factor right here a negative, and I'd go ahead and I'd end up with 10. Okay? So now here's the deal. We know we have my first set of factors right here, and I'm going to put it in 3x here, all right? And you're going to go ahead and you're going to put 1x here. We know that there is a coefficient of 1 here. Now I wanted to multiply 3 by 4. So we know that this 3 right here, when we're doing FOIL, is multiplied over here. So I'm going to take and I'm going to put that 4 here. I need this to be a positive 12, so that means that this is going to be a positive sign right here. Okay? Now, we know that when we multiply this x right here, we do my inner term, and we need this to be a negative 2, so I'm going to go ahead and I'm going to make this right here. All right? Now, if we want to go ahead and check that we did it right, we can go ahead and multiply this times this, which would give me 12x. We could go ahead and we could multiply this times this, which would give me negative 2x. And if you go ahead and you combine these like terms, you end up with 10x. All right? So that's how you go ahead and you factor a quadratic trinomial where the leading term, the leading coefficient, the value of a is not 1. Okay? Let's take a look at the second one. Let's pull out my a value. Let's pull out my c value. So I got 9, so my factors are 9 times 1, and I got 3 times 3. Factors of 4 are 1 times 4, and I got 2 times 2. We're trying to take, and we're trying to get a positive 12 in the middle. All right? Start breaking it up. Okay? All right, how are we going to get a positive 12? Well, here's what I'm thinking. I'm going to take this right here, this 3, okay? I'm going to multiply it by 2. And we know that when we do that, we have 3 times 2 is equal to 6. All right? Then I'm going to take this 3 right here. I'm going to multiply it with this 2 right here. Then I know 3 times 2 is equal to 6. Okay? So with this one, if you do 6 and 6 together, you know that you end up with 12, which is what we're looking for in the middle. So I know that I'm going to take and do this 3. So you know what? I'll keep it red. This 3x, all right, is going to multiply with 2 over here. And then I know that this 3x is going to multiply with the 2 right here. So I'm going to go ahead and put my plus sign here. I'm going to put my plus sign here. Now what you notice is both of these binomials, right, are exactly the same. So a better way to take and write this would be like this. 3x plus 2 And if they're exactly the same, you can go ahead and you can write it squared. All right? Now this one, a shortcut for that is if you notice that you have this 9x squared plus 12x plus 4. You notice that this right here is a perfect square. So you could go ahead and you could take the square root of this, which would give you 3x. And you could take the square root of this, which would give you 2. All right? You could go ahead and you could take these two terms, and you know that you're going to have 3x plus 2 squared. Okay? This is known as the perfect square trinomial. So that's a shortcut for that one. Okay? All right, next one. We have 18x squared minus 2. Now you'll notice this one, you got ax squared plus bx plus c. This one is missing my bx term. It means that there are 0 x's in the middle. Okay? That's okay. I'm going to show you a trick for this one, because this one should turn out to be the difference of two squares. First, here's what I want to do. Take a look at 18, take a look at 2. What is the greatest common factor? What's the GCF between those? Well, we're going to take out a 2. So I'm going to divide this by 2, divide that by 2, and I would be left with 9x squared minus 1, but don't forget that 2 doesn't go away. All right, it goes right here. Now, if we remember talking about the difference of two squares, you have this. You have a squared minus b squared. When you factor it, it's just equal to a plus b, and then you got the difference of a and b. Okay? So your a term up here is 9. So if I take the square root of that, I end up with 3. All right, so this one you're going to end up with 2, and then you're going to go with 3x. All right, and you're going to go with 3x because you take and you put your a term in front of both sets of parentheses. I'm going to take the square root of this. Square root of 1 is 1, so I'm going to put a 1 here and a 1 here. And notice what I do with my signs. I have a positive and I have a negative right here. Okay? I now have factored that trinomial. Excuse me, that quadratic binomial. Okay? All right, next. No different here. All we're doing is we're solving quadratic equations. And what we're doing when we're solving them is we're trying to go ahead and we're trying to find what's known as my roots or my solutions. Okay? So the same idea with these, you just go ahead and you take out the 2, take out the 2. So my factors are 2 times 1, and my factors are 1 times 2. We're trying to get 3 in the middle. So I'm thinking we're going to do this 2 with this 2, which would give me 4. And then we're going to do this 1 with this 1, and if we subtract 4 minus 1, we're going to end up with 3. Okay? So, you ready? Let me do some colors here so you can see what we're doing, okay? All right, so we said that we want to do this 2. Sorry, guys. We said that we want to do this 2, right? 2x. And it's going to equal 0. We said that we want to do that 2 with this 2 over here. So I'm going to go ahead and I'm going to put a positive 2 over here. And then we said that we want to do this 1, so I'm going to go with 1x here with this 1 here. And then if we did 2 times 2, we get 4, and we need to subtract 1. Okay? Now, here's what happens. Now we got to take and we got to solve both of these separately. So I have 2x minus 1 is equal to 0, and I have x plus 2 is equal to 0. And that's because of the zero product property. All right? When you go ahead and you solve this one right here, you're going to end up with x is equal to 1/2. And you solve this one and you get x is equal to -2. All right? So a lot of people go ahead and take and they'll do a solution set. And your solution set, your roots here are going to be 1/2. And your root is also going to be 2. Okay? Now I want you to remember, whenever you're doing these, you always need your right-hand side to equal 0. Okay? So for this one, what you're going to do is you're going to move your 10x this way. You're going to add 10x here. You're also going to take this, and you're going to subtract 8. So when you do that, you're going to be left with 9x squared plus 21x plus 10 is equal to 0. And then you go ahead and factor as we did up here in number 19. Okay? Now, another way that we can do this is to find the zeros. Okay? And to find the zeros, we do that when we have it in function notation. Okay, so when it's in function notation, you want to go ahead and you want to find the zeros. What the zeros are is they are an x value that makes the function equal to 0. That's why they're known as the zeros, okay, where your graph crosses your x-axis, okay? Up here, when you solve the equation, all right, you have everything set equal to 0. You're just solving the equation, okay? So no difference here, guys. We're going to factor this, all right? We're going to go ahead and we're going to turn it into intercept form. And remember, intercept form was this. Y is equal to A, and then you got x minus P, and then you got x minus Q. So we're really trying to find the P and the Q value here. All right? Take your 5 out to the side. You got 5 times 1. Take your 30 out to the side. You got 1 times 30. You got 2 times 15. 3 times 10. And 5 times 6. We're trying to take and we're trying to get a negative 25 in the middle. All right. We're trying to get a negative 25, and you know what? I think we have made this one too difficult because looking at this one, look at what we could have done right away. I could have taken divided this by 5, could have taken divided this by 5, and divided that by 5. Let's do that. Troubleshoot that problem, guys, all right? When you go ahead and you divide everything through by 5, you now have your f of x equal to, take that 5 out, this becomes x squared, this becomes negative 5x, and this becomes plus 6. And now all we have to do is take this 6 out, and I got 1 times 6. All right, we're trying to get a 5 here, so when I go ahead and do this, I'm going to get f of x is equal to 5 on the outside. I'm going to make my 2 sets of parentheses. I'm going to say x minus 6, x plus 1. So now I know that my zeros, I take the opposite of this. So one of my x values here is going to equal positive 6, and one of my x values right here is going to equal negative 1. So my zeros are negative 1 and positive 6. Okay? We could have done that the same way with this as a leading coefficient here of 5, but I just went ahead and I realized while we were doing it, hey, they have a greatest common factor, and the GCF here was 5, so let's take that out right away. Okay? This is factoring quadratics, okay, when the leading term, your A value here, the leading coefficient is not 1. All right?